The radical radical expressions are short, so we might do some 8-4, so that the people who are going to be gone aren't completely and totally lost. All right. Cube root of x squared. Write it using fractional exponents. Fractional exponents, meaning x to some power, that's a fraction. M over n. M over n. What do we got? X to the 2/3. X to the 2/3. How about the, oh my goodness, I can't, the 10th root of x to the x squared, let's say. X to the 1/5, right? 2 times, which is 1/5, right? So how about the cube root of x squared times the 10th root of x squared?
Just like common.
You just did the whole beginning. You just did the beginning. The cube root of x squared is x to the 2/3. You just did it. Cube root of x squared is x to the 2/3. We're just putting the two things together here. Times x to the 1/5. What do they do to the exponents? Add them. So common denominator, blah, blah, and you get x to the 13/15. Is that right? 13/15. Great. Okay, so that's the start. All right, what about the square root of 128 plus the square root of 18? Are they like terms? They are. I didn't realize the root 128 and root 18 were like terms. Are they like terms? No, but you can make them like terms. When you're going to add x plus y, you can't do anything. They're not like terms. But for roots, you can. Cube roots, fourth roots, fifth roots, whatever roots, make them like terms. Root 128 is not correct. That is not simplified. Eight roots 2. How do you break down 128 using perfect squares? Okay. Okay. Wow, Corey. Corey says that's 2 to the 7th. 128 is 2 to the 7th. Agreed? Yes, we agree. So this is one way to do it. Use your m over n fractional exponents. There's a root 2 there. We don't ever write it, but technically that's what's there. So how many 2's can you take out, Corey? 3. So you take 3 2's out, and how many stay in? which is what? What's 2 cubed root 2?
Okay.
8 root 2. Totally fine. I would do it this way. 128 is 64 times 2. What's the square root of 64? 8. Totally okay what you did, Corey. Of course, my way's better. Either way, you get 8. How about 18? So 9 times 2, which is 3 root 2. Are they like terms now? Yeah, you can make radicals like terms depending on how you break them down. Yes? All right, let's talk about rationalizing. So I want you to simplify 3 over the square root of 7. Rationalize. What do you get? 3 root 7 over 7. How'd you get that, Amit?
You multiply the numerator and denominator by root 7.
Multiply the numerator and denominator by root 7. What is root 7 over root 7? 1. Is that allowed? Yeah, absolutely. So you get 3 root 7 over 7. Okay. What about 3 over the cube root of 7? Michelle?
Multiply by cube root of 7 squared.
The cube root of 7 squared. Yes. How do you want me to write that? There's a couple ways you can write it.
I'll just write it like how I said it.
You would just write it as the cube root of 7 squared.
Or 40, yeah, 49.
Or 49, okay. 7 squared, 49, agreed? Okay, so Michelle, where'd you get that from? I mean, it's right, but where'd it come from?
Just to get rid of the cube root per se, you have to make the inside like a perfect cube.
To get rid of the inside, you have to make the inside a perfect cube. Can you cube root a perfect cube?
Yes.
Yeah, it's no different than here. Where was it? We square rooted a perfect square. Same concept. So, what is that? What's 3 times the cube root of 7 squared? It's not that, it sounds much worse than it is.
3 times root cube root 49.
3 times the cube root of 49. Here we multiplied, where is it? We just multiplied 3 times root 7 is 3 root 7. So here we're multiplying 3 times cube root of 49. That's 3 times the cube root of 49. What's in the denominator? 7. Okay, so let's go through another way you could look at this. So the whole reason I gave you the fractional exponents to start with, the whole reason why we did this to start with, so that you can do cube roots as fractional exponents if you want. If you just see, great, go for it. So I'm going to do the same problem in another way. Cube root of 7. How can I write that using fractional exponents? 7 to the 1/3. Yeah? All right, so I have a third, but I need 3/3 to make it whole. Would you agree with that? What's 3/3? There we go. So how many thirds do I need to finish this off? 7 to the 2/3. It's another way to look at it. Same concept. M over n. This is the cube root of 7 squared. Cube root of 7 squared. They're exactly the same thing. One of them you're looking in radicals. One of them you're looking at as exponents. 3 times 7 to the 2/3. over, is that right? Yes, we're like silent today. Is that right? Okay, this is not a great way to write it. You should, I mean, this process, A-okay. You really should write it though as 3 times the cube root of 39. I don't care how you get there, but this is how you should write it. How do you rationalize root 2 plus root 5 over root 5 minus root 2? Oh, okay, that's fun. Keep it all right. That works. No radicals in the denominator. No cube roots, no 4th roots, no 20th roots, not in the denominator. So the easiest way to simplify this, by far the easiest way, that's 1. Yes? No. You cannot reduce. This is a binomial over a binomial. You can't just decide to cross things off in the middle. No. You cannot reduce a part of a binomial. 2 terms, binomial, you cannot just randomly reduce. Absolutely not. If they matched exactly, root 2 plus root 5, like if this was a plus sign, it's great, but it's not. Okay, so what do we do? Yeah, Michelle.
You multiply both, you multiply by root 5 plus root 2 over root 5 plus root 2.
What's that called? Michelle says multiply by root 5.
Is it conjugate?
There you go. This is called the conjugate. It's called a conjugate. A plus B, A minus B, they're conjugates. A plus B, A minus B are conjugates. Oh, I put it in the wrong place. It should have gone down here, but I was still like recovering from my heart attack that I almost gave myself. That's right, a self-induced heart attack. Well, you know, sometimes I have to refresh your memory to distribute combined like terms, blah, blah. No radicals should be left in the denominator. If you have a radical left, you either multiplied by the wrong thing or you did your distributing incorrectly. That's the whole point of this conjugate. What do you got? What'd you get, Nate? 7/3?
Yeah.
What else? Nobody got anything besides 7/3. Angelina?
2 root 10 plus 7.
10, 2 root 10 over what?
Plus 7 over 7. I got 7 plus 2 root 10 over 3.
7 plus 2 root 10 over what?
3.
Okay, well I see 7s and 3s, so what else we got? You got, Amit, you got this one? How many of you got one of these 3 answers? You got one of these 3. Okay. Where should I start? FOIL, that's what some of you learned. Root 2 times root 5 is root 10. Root 2 times root 5 is root 10. Plus, what's next? How are you doing? Okay, root 2 times, what's root 2 times root 2? 2. What's root 5 times root 5? 5. And then this is another root 10. There should be no radical left in the denominator. If there is, you made a mistake. You either chose the conjugate incorrectly or you multiplied incorrectly. Root 5 times root 5. 5. Fantastic. Plus root 10 minus root 10. That's the whole point. It's like a difference of 2 squares already factored out. Plus root 10 minus root 10 CU. CI, I should say. Root 2 times root 2. And then it's minus. Yes? Okay, so that you got 7/3. What happened to the radical? Root 10 plus root 10 is 2 root 10. 2 plus 5 is 7 over 3. Okay, so those of you who didn't get this, okay, check your mistake, make a correction. Check your mistake, make a correction. Okay, let's do something. Let's do some that are like really messed up. No, because you know what happens if we don't do the ones that are really messed up. Then I hear you never gave us anything like that on the test. It was so hard. That's exactly what you do. Not in front of my face, but it's exactly what you do. Maybe a nicer voice. Okay, I'm going to make it up, which means it's going to be ridiculously bad. How about 6 plus 7 over root 3. Oh, I'm digging it already. Oh, wait. Over. How about 1 minus 2? 1. No, you can't do 1 minus 1. That's 0 in the denominator. It's asymptote on the graph. Is that what you want to do? I didn't think so. 2 root
4.
square root of 4 is 2. Guys, 2/3.
Why would you say that?
Nate, your classmates aren't too happy with your choices. Okay. Oh, no. This is not good.
It's not over.
2 over root 5.
Because if you have fourth root of 42, 49, that explains.
Okay, I'm not lying. I'm not quite sure where we're going to go with this one. Oh, I do know what we're going to do. Sometimes it takes a while to come to me. All right. Here's a suggestion. Look at the numerator and the denominator separately. I hope that's the right suggestion. This problem could take us 15 minutes. I would recommend we look at the numerator and the denominator separately. I think that's going to get us where we need to go. I'm honestly not sure, so let's play around. Okay, honestly don't think it's going to be that bad. I'm not just saying that. I think this is going to work out okay. Numerator, I'm just going to pull it out to the side. Numerator. Ik, no can do. How do you get rid of the ik? Yeah, multiplied by root 3 over root 3. Fancy form of 1. Is that allowed? Of course it is. Six plus 7 root 3 over 3. 6 plus 7 root 3 over 3. You okay? Okay, I don't like this. It's not wrong, but eh. So what should I do with the 6?
Yeah, it's
Any ideas what I should do with the 6 so that I want to combine these?
Well, multiply by 3 and
Okay, so what is that? 18 thirds. So this is 18/3 plus 7 root 3 over 3.
Oh, because you have to do it.
So I took 16 and I took 6 and I made it 18/3.
You can add it over one big.
I'm gonna write it as one like fraction. So this now becomes 18 plus 7 root 3 over 3. Yes? Okay. I'm not done. One minus 2 over root 5. We're going to do exactly the same thing to the denominator that we did to the numerator. Start. We're going to do the denominator. You're going to start the denominator. I'm going to start it. Whatever. Doesn't matter. We're going to do it. Where should I start? Nate?
Multiply numerator and denominator by square root 5.
Great. I'm going to multiply by root 5 over root 5, which gives me 1 minus what? Fantastic. 2 root 5 over 5. Now, I don't like that. I want to combine them.
Multiply on 1 by 5.
Great. So this is 5 minus 2 root 5. 1 is the same thing as 5/5. Yeah? Okay, so that's my denominator. Now, I'm going to divide the whole thing. So my numerator, which was 18 plus 7 root 3 over 3, all over 5 minus 2 root 5. These numbers are going to get big, I think.
Yeah, it's risky.
I think these numbers are going to get big. Oh no, it's a complex fraction, your absolute favorite.
When was the last time we did a complex?
I don't know. This semester, sometime. What do you got for me? What do I do?
Multiply.
Yes, multiply by the reciprocal.
Reciprocal.
So this becomes 18 plus 7 root 3 over 3 times 5 over 5 minus 2 root 5.
Oh boy.
18.
There's a radical in the denominator. Gross, gross. That's what we can do. What do I need to multiply by?
What do you first solve?
There's nothing to solve out.
I mean, what do you first solve?
What do you want me? Brian wants to know if we should simplify it. What do you mean by simplify it?
How do you
First
simplify?
multiply to
You want me to distribute? Is that what you mean? Brian wants to know, should we distribute first? What do you want to do? There's no right or wrong answer to this question.
Yes, we want to.
Okay, Corey says yes, he wants to distribute. There's no right or wrong answer. Do you want me to distribute the numerator as well?
Yeah.
All right, 18 times 5. 90? 90. So it becomes 90 plus 35 root 3 over 15 minus 6 root 5? Yes? Okay, I would not have distributed the 3 because now I have to multiply by 15 plus 6 root 5, and 15 and 6 and multiplying those, I would have left the 3 out and put it in later. Not wrong, but now all of a sudden the numbers get big and your propensity to make mistakes increases. So I would have just said, put it off to the side and then done it later. But that wasn't the choice you made. So what should I multiply by? 15
Plus
plus 6 root 5 over 15 plus 6 root 5. Okay, don't pull out your calculator. Have fun.
Thank you, Jenny.
Don't pull out your calculator.
Oh, wait,
Yeah.
it's minus, not plus. That would plus.
Yes. Oh, take out the 3 first?
Yeah.
After you do the long way. After you use your brain and do all the calculations.
Use your brain.
Oh, well. So I would have left it as. Having a great time. So I would have left the 3 out here. And I would have done 5 minus 2. Yeah, I'll show you. I had to think it through for a minute. Ooh, 15 times 90, gross. 15 times 9 and a 0. What's 15 times 9? 1450? 13. With the 0. Yeah. Multiply it out, you get 1350. I'm trusting that you guys know what to do. 90 times 6, 540? Oh, and none of these are going to combine. 35 times 15. 35 times 15.
5 times 5.
525? Thank you. I just lost my place.
Root 3.
Root 3. Thank you. And then, oh my gosh, 35 times 6 times root 15. What's 35 times 6?
210.
Woo! 225 minus 30. When you distribute this, you get 36 times 5. What's 36 times 5? 180? 180? Oh my goodness. And you know what? I bet you this all reduces because 1350, 540, 5. Oh, you know why it all divides by 3, I bet, because you guys chose to multiply by the 3 to begin with. It does, doesn't it? Okay, 13. Okay, hold on. I don't want to write this 18 times. 225 minus 180 is 45. Okay? Yes? Okay. The numerator, what can you factor out of the numerator?
5.
5? Okay, help me. I can't divide by 5. 1 something. What's 1350 divided by 5? 2.
27.
Thank you. 180? 108?
105.
This is 105?
42.
You can blame Brian and Camille because this is what they wanted to do.
Brian.
That's Corey.
No, I believe it was definitely Brian.
It was Brian.
That was me. That's what
It's 100% okay. But the numbers are huge. And then I'm thinking, oh my God, we have to reduce this. So 5 over 45 is how much? You get 9 in the denominator. So this becomes 270 plus 108 root 5 plus, wait, 108, yeah, plus 105 root 3 plus 42 root 15 all over 9.
Wow. 3.
What? Don't you tell me I made a mistake.
No, you can factor out of 3.
So we could have factored out a 15 to begin with? Why didn't you say anything?
We didn't know.
Seriously, no one said anything?
It's also,
Ah!
it's also 402, not 42, I think. No.
Oh my
God!
No, that's good.
I was wrong.
And this color doesn't erase well, so now I gotta use the spray, and the spray takes forever to dry. Okay, let's try again. So now I'm hearing that what's in red divides further by something? By another 3? Okay, so this is what's gonna happen. I'm totally gonna make you do it. No, we'll do it together. We're gonna go back to this is 100% okay. See how tedious it is? I mean, like almost all of you have like tuned me out. You're not even listening to what I'm saying. This is tedious. How do you do it where it's not so tedious? So I'm gonna go back to, was it here?
Yes.
It was here? So I'm just gonna rewrite it. And we're not gonna distribute the 3. Okay, so here's what happens. Are the numbers pretty? No, but they're not as bad as what we just did.
We all learned our lesson.
Okay. Yeah, I believe I said it was probably going to be nasty. I wasn't wrong. I don't lie usually.
We said it was 15 minutes.
What did I say?
Longer than
I'm
15.
good at what I do. I'm good at. Okay, so let's not distribute the 3. Let's not distribute the 3. We're still going to multiply by. See what happens when you don't distribute the 3. See how huge this 15 and this 6 becomes. Here, if we don't distribute the 3, we're going to multiply by 5 plus 2 root 5. 5 and 2, way better than 15 and 6. Agreed? So how do you know when you should distribute? Just look at the numbers. Do I really want to multiply 3 by, you can think ahead, I know you can. Do I want to multiply by 15 and 6, or do I want to multiply by 5 and 2? And I think that's a logical choice for most of us, for all of us. So I'm going to multiply by 5 plus 2 root 5 over 5 plus 2 root 5. Okay, we'll go, what time is class now? 12:15? 20, 25, what time is it?
It's 12:25.
Okay, so I'm just gonna start it, okay? So this becomes, I'm gonna leave the 5 in the front. I'm just gonna start it. You need to focus though, don't tune me out. I know it's hard. 5, and then I'm gonna multiply by 18 plus 7 root 3, 5 plus 2 root 5. I essentially just changed the order, right? A times B times C, C times B times A, whatever. And then the denominator is going to be 3 from here. I have to multiply this out so I can get rid of the radicals. 5 times 5 is 25. Plus 10 root 5 minus 10 root 5, see ya. 2 times 2 is 4. Root 5 times root 5 is 5, so you get minus 20. Yeah? Okay, what's 3 times, look at the denominator. What's 3 times 5? Wasn't that the denominator in the answer, I think? Oh, and you guys were telling me I should take out a 9 or whatever. I think the denominator was 15 or something like that. So, this one, and then you would distribute, combine like terms, and it becomes over, what did we say, 15? Distribute it all, combine like terms. Oh, da.
You could just.
Yes. Don't even need to multiply the 5 out. 5, 15, 3.
Oh, now it makes sense. That's like there's no 15 is a denominator.
You need to distribute. I mean, like, you're not done. Multiply this all root out. Blah, 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 blah. Last time we listened to Brian,
Come on. It was Corey.
it was
I
not.
listened to
Take
you.
ownership.
Yes, I was.
It wasn't a mistake. It was
Yeah,
It was a
I
good
have to be the big
experience.
elephant here.
Okay, we have homework due today. I have no idea what it was about. Oh, reducing.
Don't be the big elephant in the room.
It's, you know what? I'm being serious. It's a great learning experience to say, oh, there's got to be a nicer way to do it. And that's great.
It was cool. It's a nicer way to get out.
Questions on the board?
It was actually cool.
Nice way to get
Yeah,
out.
it's just the
I
fun
would have been
question.
texting me that.